Moving on, now that money is involved, there are some critical differences between the internet and distributed ledger technology. When it comes to information or content in the form of Word documents, audio files, or videos, they can simply be copied and pasted onto the internet and distributed to whoever may be interested. On the other hand, that cannot be done with money because if you copy and paste it, then it no longer retains its value and people can be cheated. This is known as double spend. So, how is this problem solved? Through the use of cryptography, which has its roots in Greek for hidden secret. Cryptography is applied to encrypt information for secure communication and protection from third parties. Remember that Bitcoin is information money, so that whenever you buy Bitcoin, what you're really doing is paying money for information. Conversely, when you sell Bitcoin, you are paying information for money. And it's not just one or two computers, but a network with millions of computers transacting continuously such that a market is created with supply and demand for Bitcoin or information money. Meaning, the encryption of this information is so valuable that a global marketplace has developed to facilitate its exchange. And the security is so airtight that Bitcoin has never actually been hacked. And that's because the information is encrypted using a method by the NSA called the Secure Hashing Algorithm, or SHA-256. Without getting too technical, a hashing function is basically a unique fingerprint for any set of data. Here's a demonstration. A SHA-256 calculator like this one can be found from a quick Google search. And like this sentence, anything you write here will be converted into a unique hash, such as this string of letters and numbers, which is extremely difficult, practically impossible to reverse engineer. So when it comes to hashing Bitcoin, the data is even more unique, as it is tagged with the time at which the transaction took place, a summary of the current transactions that are grouped together before they're finalized, a summary of all the past transactions that have occurred, and something called a nonce, which for our intents and purposes is another variable added to make this whole thing even more secure. The result is a hash or a fingerprint that is unique enough such that it cannot be copied, and so it guarantees protection from the double spend problem.
Perhaps you're wondering, why go through all this trouble when you can already send money anyways through portals like Cash App, Venmo, or Zelle? That may be, but the difference lies in the method of transaction. Whereas Bitcoin empowers us to exchange money in a peer-to-peer manner, these apps use what is called a client-server model, which looks a bit like this. When you send money to your friend or family using these apps, you are the client interacting with a server that is routing the transaction through the internet. And this server is housing a database or a ledger of entries representing transactions between clients or people. So its main function is simply to make sure that there remains a balance without any errors. As a result, the ledger is centralized, and the server represents a middleman that validates these transactions. Therefore, double spend is not much of a concern. On the other hand, a peer-to-peer network like Bitcoin has no middleman. Instead, the ledger is decentralized and distributed amongst the network of computers. Hence the term distributed ledger technology.